Now, welcome back to our third part. So, here's the deal. We have this dilemma earlier in which we have two structures of CO2, which may both be possible as the final structure of CO2, but I will tell you that those two are not possible. Okay? So, hindi pwede yung dalawang yan. So, let me introduce you to the concept of formal charges. So formal charges are, in a sense, if you cut those bonds, pag pinutol mo yung bonds na to, sorry, I don't know where the marker is. Ayan. Okay. Okay. Sorry, wait lang ha. Yeah. So if you cut this bonds here, okay, pag pinutol mo yan, each atom will have their own electrons, right? Let me do this. Yan. Yeah. If you count the number of electrons immediately surrounding the atom, that means it will not extend to the other end of the bond. If you count that and subtract it by its valence electrons, then you have the formal charges. So formally speaking, the definition of formal charge is that it is the charge of an atom where you subtract the valence electrons from the number of electrons surrounding that element in a molecule. Medyo magulo, no? Pero, ganito na lang gawin natin in order for everything to be much easier to approach. So, this is the formula for a formal charge. So, each atom in a molecule has their own formal charge. And the formula that we will use is a simplified one. So, let's call it valence minus lines minus dots. Okay, so let's use this formula, valence minus line minus dot. So that will give us the immediate number of electrons that is closest to that atom. Diba sabi ko kanina, burahin natin tong line. Okay, so these 4 electrons here, only 2 of them are close to the oxygen. The other 2 is close to carbon. So parang ganun yung idea. So that's why instead of counting these dots, parang sa octet kanina, we will not do it that way. Instead, we'll just count the line. Okay? Ilang line nandiyan. So let's do it. So for formal charge, sige, let's focus on oxygen here. So for this oxygen, what's the valence electron of oxygen? What is its group number? It is in group 6. How many lines are close to this oxygen? You have 2 lines, 2 bonds. And how many dots do you see around oxygen? You have 1, 2, 3, 4. 4 dots. So 6 minus 2 minus 4 is 0. This means that this oxygen atom has no formal charge. Now, how about this carbon? Carbon is in group 4, so it's 4 minus the number of lines surrounding carbon. We have 1, 2, 3, 4. Minus, do you see any dots around carbon? The lone pair? No. So 0. 4 minus 4, 0. How about this one? So this oxygen atom is in group 6, so 6 valence electrons, minus 2 lines, minus how many dots? 4 dots. Paano naging 4 yun, sir? These are lone electrons, lone pair, pero you count them individually, okay? So 6 minus 2 minus 4 is 0. So for this molecule, each atom do not have a formal charge, okay? So just save it up for later. Let's try to get the formal charge of these atoms here sa baba. So beginning with the same sequence, so this oxygen, its valence electron number is 6, group 6. How many lines do you see around this oxygen? You have 3 lines. How many dots do you see around this oxygen? You have 2 dots. So 6 minus 3 minus 2 is positive 1. So do you see the difference? So next we have the carbon. So this is the carbon. What is the valence electrons? So valence electrons is 4 valence electrons in group 4. We have 4 lines here and 0 dots around it. So 4 minus 4, 0. And then for the last one, we have oxygen. We have this oxygen here. It's in group number 6, so 6 valence electrons. You see 1 line next to it. 6 minus 1 line minus how many dots? 1, 2, 3, 4, 5, 6. 6 dots. So 6 minus 1 minus 6 is negative 1. So now, without any idea of what I'm going to say next, which do you think is better? The molecule in which all atoms do not have any formal charge? In that case, puro zero formal charge niya sa taas? Or the molecule below, in which the atoms have varying formal charges? Okay, so the answer to the question earlier is that we prefer a molecule to at least have no any formal charge. So that means this is the best structure for CO2. And in fact, if you Google it, so let me show you. Let's Google this thing. Okay, so let me just type CO2. Tingnan niya. For CO2, ano yung structure niya? Let's go to images. Tingnan niya, oh, di ba? So that's the structure for CO2. That is the only possible structure because that structure has at least no formal charges, no, meaning it's very stable. So that means after drawing the molecule, you identify the formal charges, and in order for you to be sure that that is the correct structure, number 1, as much as possible, amas. So that's not the the terrorist group. Ano lang, as much as possible. Mali. Sorry. AMAP pala. As much as possible, we want formal charges to be close to 0 or at least 0 at all. So as much as possible, formal charges must be close to 0 or 0 at all. So this is the best case scenario. Right? For instance, in our CO2, 0 lahat ng formal charge, so we prefer that one. But what if we cannot really get a 0 formal charge for all molecules? So here's the second criteria. If that is not possible, if this is not possible, it's just close to 0, then here's the idea. We want the less electronegative atom to be positive and the most electronegative atom to be negative. So meaning, if you have the most electronegative atom becoming positive in formal charge, that's a bad sign. Because remember, electronegative atoms really want electrons. So by giving them a positive charge, they will really get unstable, diba? In our case, this one, let's look at this oxygen here. So this oxygen is the most electronegative atom in the molecule. But look at the formal charge, it's positive. Really don't like positive things, no? Okay siya kung 0 siya. But it's not okay if it's positive 1. You may argue, sir, negative 1 naman yung isa. Hindi pa rin. So, as much as possible, we want to make these oxygens 0 or negatively charged. Okay? So that's how you decide if a molecule is correct. So in my next video, I will share with you the different examples that I will present you following the rule of NASU rule and the formal charges. Okay, so stay tuned.